Alright, so for the Q4 day 16 homework, it was multiple choice. Problem 88. The trick, well, we know that we have a 6 feet or 6 foot tall person. And we know that the street light is 15 feet. And the trick was making or considering the similar triangles. And these are two right triangles. Okay? So this is 15, this is 6. Now this is going to be x. The entire thing is going to be y. We'll call that y. So that's the entire that base for that big triangle, and the base for the small triangle then turns out to be y minus x. So technically you have these two similar triangles. Okay, so one thing we know about similar triangles is that corresponding parts are proportional, or we can set up a proportion that looks something like this. 15 over 6 equals y over y minus x. Okay, and then from this point we can cross multiply. Some of you guys probably know this as the butterflies. Do that. You do that. And we now have 6y equals, it's going to be the distributive property. So you have 15 times y minus x. So it's pretty much 6y equals 15y minus 15x. Okay. So what we have is 15x equals 9y. All I did was I added the 15x and I subtracted 6y. Divide by 15 to get x equals, oops, I should have divided by y. I'm sorry. Let me go ahead and, it was 15x equals 9y. And if I divide by 9, I get y equals 15 over 9x. Okay? So now this is the function that we're going to differentiate. Pretty much y equals 15 over 9x. The thing here is that this is a related rates problem. And related rates problems are differentiated with respect to time. Okay, so some of you guys might like it better if I write this as y equals 15 over 9x. And we're going to differentiate this with respect to time. So we're going to take the derivative of both sides with respect to time. And don't forget that 15 over 9 is just a constant being multiplied to that function x. So when we take the derivative of 15 over 9x, it's really just the derivative of x. The derivative of y is just 1 times dy dx. I'm sorry, dy dt. Because it's the variable y with respect to time. So it's kind of like when we were doing implicit differentiation. This one is 15 over 9 times 1 times dx dt. Okay, So all we have to do is plug in the value for dx dt and we are done. And we actually know what dx dt is. Okay, in the problem they tell us that this person is walking away from the base of the street light along a straight path. So this path is at a rate of 4 feet per second. Okay, so that's our dx dt. That is our derivative of x with respect to time. And it makes sense that we're differentiating with respect to time, because if we think about it, this is a person that's walking away, and as he's walking away, his shadow is changing with respect to time, and his distance from this street light, the distance is changing with respect to time. Okay, so this is dx over dt is equal to 4, and it's actually in feet per second. So we have dy dt is equal to 15 over 9 times 4 feet per second. 15 over 9 is 5 over 3. So this is 5, this is 3. So we can say this is 20 over 3 feet per second, which is approximately 6.667. And it's in feet per second, but we don't see the answer. 6.667 is not on there, and here's why. We want the derivative of y minus x. So the derivative with respect to time of y minus x. Again, this is just the implicit differentiation, so this is just the derivative of y, which is 1 times dy dt, minus the derivative of x with respect to time, so that's 1 times dx dt. We actually know what dy dt is. That came out to be the 6.667 in feet per second, minus the 4 which was the dx dt, the 4 feet per second. So once we do that, we see that we get 2.667, and it's in feet per second, so it's B. Okay, and that's that problem.